average velocity and vector of the average velocity. Definition: average velocity. The average velocity is determined by the total covered distance during the whole trip divided by the total time taken in this trip. Total distance over total time equals average velocity. Second, vector of the average velocity. If a particle takes two positions A and B, between two successive moments T1 and T2 respectively, and let S be the displacement vector during the time interval T2 minus T1. So, to determine the vector of the average velocity, we use the rule VA equals R2 minus R1 over T2 minus T1. R2 minus R1 equals S. Again, the average velocity vector equals S over T2 minus T1. T2 minus T1. Or you can say total time. Examples. We start with this example. The opposite figure shows the relation between the time and the distance. The time in the horizontal axis and the distance on the vertical axis. For the motion of a cyclist, the motion starts from the point O here in a straight line. Find the vector of the average velocity and the average velocity. So this graph to represent a motion on a straight line of a certain particle. So it covered 100 meters on the first 5 seconds, and the location of the particle at the point A, 5 and 100. After 5 seconds, it covered 100 meters, and another 5 seconds, it returned back in this 5 seconds to be at the point B of coordinates 10 and 40. So the final position of the particle, we consider it at the point B after 10 seconds, 40 meters from O. And we can represent this motion on a straight line like this. The body started its motion from O. It covered 100 meters to be at the point A, and it returns back 60 meters to be at the point B. So OB represents the displacement, but the covered distance equals 100 plus 60, which equal 160. 100 plus 60 equals 160. And the total time from the beginning of the motion to reach the point B equals 10 seconds. So the total distance equals 160, but the displacement equals 40 n, considering n is a unit vector in the direction of the motion, in the positive direction. So now it's easy to calculate the magnitude of the displacement equals 100 minus 60, which equal 40 meters, and S equals 40n, 40n, because S is a vector, displacement vector equals 40n. And to determine the vector of the average velocity, VA, we write the rule. VA equals S over T2 minus T1 over the time interval. S equals 40n over 10 minus 0, which equal 4n. And its magnitude is 4 meter per second. And VA, it is not a vector. It is the average velocity equal total distance over total time. Total distance equals 100 plus 60, 160 over 10, which equals 16 meter per second. So there is no direction for the average velocity. It is only express the magnitude of the average velocity, which equals 16 m, 16 meter per second. But when you talk about a vector, the vector has a magnitude 4 and a direction in the direction of n, such that n is a unit vector in the direction of the motion. The opposite figure shows a chart for a curve of a rat escapes from a cat. Redraw this figure if the rat escapes from the cat with double its speed. Again, the required is to redraw this figure if the rat escapes from the cat with double speed. Double speed means double distance in the same time. Here, take a point like this. What that mean of this point? After 1 second, it covered 1 meter. So to double its speed, it must double the distance in the same time. So it will be 1 and 2. 2 meters in 2 seconds. To double the speed, it will be 2 and 4. Okay? 3 and 3. It will be 3, and we double this, it will be 3 and 6. 4 and 3, it will be 4 and 6. 5 and 2, it will be 5 and 4. 5 and 4. 6 and 1 meter. So it will be 6 and 2. So this figure to represent the motion of the rat in double speed. Double speed means double distance on the same time. I hope you got it. Example, a cyclist covered 30 kilometers on a straight road. With velocity 18 kilometers. And then he returned on the same road and covered 20 kilometers in the opposite direction with the velocity 15 kilometers per hour. Find the average velocity and the average velocity vector during the whole trip. Solution. will represent the motion of the cyclist on this straight road. It starts from A and reach to B. The distance here is 30 kilometers in velocity 18 kilometer per hour. Okay, and it returns back from B to C here. It covered a 20 kilometers in velocity 15 kilometer per hour to be at the point C. Now find the average velocity and the average velocity vector. We consider n as a unit vector in the direction of the motion. T1 equals D1 over V1, which equals 30 over 18, equals 5 over 3 hour. To calculate the average velocity, we know it's equal total distance over total time. So we must calculate the time first. So the time T1 to represent the time taken in this 30 kilometer. T1 equal D1 over V1, which equal 5 over 3. The time equals the distance divided the velocity. And T2 equals second distance over its velocity. So it's equal 20 over 15 equals 4 over 3 hours. And the average velocity equals total distance 30 plus 20 over total time, and the result will be 50 over 3 kilometer per hour. Okay, now the average velocity vector equal S over T, the displacement over the time, over total time. Displacement equals 30 minus 20 in the direction of n, which equal 10n over 3. And this is the average velocity vector. To calculate the displacement, again S equal 30 minus 20, because the body or the cyclist covered the 20 kilometers in the opposite direction of 30 kilometer. Question 5. A bicyclist covered a distance 25 kilometer on a straight road with velocity 15 kilometer per hour. Then he covered a distance of 7 kilometer in the same direction, on the same direction, with velocity 7 kilometer per hour. Find the average velocity vector and the average velocity during the whole journey. We will represent it on the solution. Here it starts from A to B, then from B to C. From B to C. From A to B, it's 25 kilometers. Then from B to C, it is 7 kilometers on the same direction. On the same direction. So we consider the opposite direction in the direction of the unit vector n. We consider the positive direction in the direction of the unit vector n, and we calculate the time taken on the first trip or on the first stage. It's 25 over 15 equals 5 over 3. 25 is the distance over the time equals 5 over 3. And T2 equals 7 over 7, which equal 1 hour. The time equals the distance divided by the velocity. So the total time T equals 5 over 3 plus 1, which equal 8 over 3. We need it. We need the total time to calculate the average velocity vector. S over T equals 25 plus 7 in the direction of N. Note that we add in the direction of N because they are on the same direction. So 25 plus 7N over the total time 8 over 3, which equal 12N, the direction of N. And VA equals total distance over total time. VA to express the average velocity. 25 plus 7 over total time, which equal 12 kilometer per hour. Example 5. A particle takes two positions, A and B. A is 5 and 2, B is 9 and 10, between two successive moments, 3 seconds and 7 seconds, respectively. Find the direction of the average velocity of a particle during this time interval, then find the magnitude of the direction of this average velocity. Again, find the direction of the average velocity and find its magnitude. So the required is to find the average velocity vector. So we have the first position vector, or the first position at the point A, 5 and 2, and the second position 9 and 10 according to the given. So from this we can calculate S. S equals R2 minus R1. S equals R2 minus R1. Okay. S equals 9 and 10 minus 5 and 2, which equal 4 and 8. 9 minus 5 equal 4. 10 minus 2 equals 8. And we can put it in this form: 4i plus 8j. I and j are the two fundamental unit vectors in the direction of x and in the direction of y. So VA, the vector of average velocity, equals S over T2 minus T1. VA equals S over 7 minus 3. T2 minus T1 from the given. T2 equals 7, T1 equals 3. So the result equals 4 divided 4 minus 3 equal 4. 4 divided 4 equal 1. And the 8 divided 4 equals 2. So the average velocity vector equals I plus 2j. How we determine its magnitude? So the magnitude of the average velocity vector equals square root of 1 square plus 2 square, which equal root 5 unit of velocity. What about its direction? And it makes a polar angle with x-axis equals tan minus 1 y over x. So it's equal 63 degrees, 26 minutes and 6 seconds.